Welcome to my channel. My name is Bhawa Singh, and today we are going to discuss several other questions on CI/CD. This is round 2 of CI/CD interview questions. You might have already seen one video on CI/CD. If not, then feel free to watch it and the link is in description. Alright, let's begin our second round of questions on CI/CD. And our first question today is, what is the version control system? Version control, like GitHub, GitLab, etc., is a system that records changes to code over time, allowing developers to track revisions and collaborate efficiently. It helps manage code history, resolve conflicts, and enables rollback to previous versions if needed. Second question is, how does the version control system integrate with CI/CD? To integrate CI/CD with version control like Git, you need to connect your source code repository to a CI/CD tool, but there are some post-integration steps also for configuring CI/CD pipeline to implement complete CI/CD pipeline. Let's take a look at it. First of all, we need to choose a CI/CD tool, for example, Jenkins, GitHub Actions, GitLab CI, Circle CI, etc. To choose a right CI/CD tool, it can depend on various factors like project's tech stack, ease of integration, scalability, community support, and cost. In second step, we need to connect repository to CI/CD tool. CI/CD tools can be inbuilt in some of the version control systems, for example GitLab with GitLab CI and GitHub with GitHub Actions. If the CI/CD tool is external to the version control system, for example Jenkins, then you need to add Git credentials, install Git plugin in Jenkins, and configure webhook or polling. Third step is to create pipeline configuration by using a config file in your repo root folder. For example, if CI/CD tool is a GitHub action, then main.yaml file. If CI/CD tool is a GitLab CI, then .gitlab CI yami. If CI/CD tool is Jenkins, then Jenkins file. You need to configure this file according to your CI/CD tool by defining stages like build, test, deploy, etc. Fourth step is to trigger a pipeline from Git events. Here, events can be push events, pull request or merge request, tag creation, scheduled car on job. Trigger event settings we need to configure in CI/CD tools config file, which we have discussed in step 3. Fifth step is to secure access, and this we can implement by storing secrets, for example API keys, tokens in encrypted secret managers provided by the CI/CD tool. Also, remember guys, avoid hard coding credentials. Sixth point is to monitor and optimize the CI/CD pipeline so that you can use logs to track pipeline results. You can add notifications on Slack or email, etc. Alright guys, now we know that what is version control system and what all steps we need to take to integrate it with CI/CD. Let's move on to the next question. And our third question today is to explain the role of version control, for example Git, in CI/CD. Version control is very essential for CI/CD because it can track code changes, enable collaboration, and trigger automated builds and deployments. Let's have a look at its roles in steps. Firstly, in CI/CD, version control acts as the single source of truth by maintaining the definitive, up-to-date code base for building, testing, and deploying applications. Secondly, version control system triggers CI/CD pipelines on changes, for example on code push or on pull request. Third point is, the version control system enables collaboration through branching and merging. Fourth point is, it tracks history, changes, and who did what. Fifth point is, it supports rollback if something breaks. Sixth point is, it ensures consistency across the environments. So to conclude it, we can say that, without version control system, CI/CD would have no reliable starting point. Let's move to the next question. What are the stages in a typical CI/CD pipeline? Well, there are a couple of stages. Some belong to continuous integration, and others are part of continuous deployment. As you can see, the number of stages are now shown on the screen, separated into CI and CD. Let's start by walking through the CI stages. Our first step is code commit. Now technically, code commit is a trigger event, not a formal stage in the pipeline. But I've included it here just to highlight this is where everything begins. Developers push code to a shared Git repository, like GitHub or GitLab, and that action triggers the pipeline. Next up, we have code checkout. This is where the CI tool pulls or downloads the latest code from version control. Once the code is fetched, it begins running the next defined stages, for example, build or test. The next stage is static code analysis or linting. Here, the tool checks your code quality, things like syntax, formatting, and best practices. It helps catch silly mistakes early. Then comes the build stage. This is where the source code is compiled and dependencies are downloaded or resolved. You can also package the code here into executable files like .jar, .war, or even Docker images. If you're doing packaging here, then you won't need a separate packaging stage in CD because it's already done. After build, we move on to unit testing. Here, individual functions or classes are tested in isolation just to make sure they work as expected. And finally, we reach the merge check stage. This is like a gatekeeper. It ensures that only tested, reviewed, and verified code gets merged into the main branch. So those are the CI stages. The core foundation before code moves further down the pipeline. All right, now let's have a look at the CD stages. That's continuous delivery or continuous deployment, depending on your model. The first stage in CD is packaging or artifact creation. As we discussed earlier, if this wasn't already done in the build stage, we do it here. This is where we build the final package, like a JAR file or a Docker image, and upload it to an artifact repository like Nexus or Docker Hub. Next up is integration testing. This is where components that already passed unit tests are now tested together. For example, API plus database or front-end plus back-end, making sure they work correctly as an integrated system. After that, we move to staging deployment. This means we're deploying the code to a pre-production environment for final checks, a dry run before production. Now, let's have a look at E2E stage. End-to-end testing is a type of testing where the complete flow of an application is tested, from start to finish, to ensure that everything works together as expected. It simulates real user scenarios to validate the system as a whole. E2E stage is usually required before production deployment and after staging deployment to test the real environment. Then comes the approval step for delivery. In continuous delivery, this is a manual approval gate. A human, maybe a release manager, reviews and approves the release before it can go live. And finally, we have production deployment. Now, if you're following continuous deployment, this step is automatic. No manual approvals required. The release goes straight into production, fully automated, once it passes all the prior checks. And that's the flow of CD stages, packaging to production, with the right blend of automation and control. Now guys, you're well aware of the CI/CD stages and you can easily explain them. Our next question will further test your knowledge. And yes, it's again from the CI/CD stages. So here's the question. What happens when a build fails in CI? Let's break it down. First of all, when the build fails, the pipeline should not move ahead to the next stage. Why? Because the code couldn't be compiled and the package or build couldn't be created properly. So what exactly happens? Number one, the pipeline automatically stops. That means it won't continue to the next stage. Number two, an automatic failure notification is triggered. It could be through email, Slack, or any integrated channel, and it's sent to all the relevant stakeholders. Number three, the logs of the failed build are automatically captured. These logs are crucial for understanding what went wrong. Number four, the build artifacts will not be generated. Since the build didn't succeed, there's nothing to release or deploy. Next, the developer investigates the reason for the failure. They look into the logs, analyze the error, and identify the issue. And finally, once the issue is fixed, the updated code is recommitted, and the CI pipeline is triggered again from the beginning. That's what happens when a build fails in CI. Every step is automated to catch problems early and keep your pipeline clean. Guys, you're going to be surprised by our next question. And yes, it's once again from the CI stages. So here it is. How do you handle test failures in CI/CD pipelines? Well, there are some key steps you need to follow to deal with a failed test stage. Let's go through them. First of all, when the test stage fails, the pipeline will stop right there. This prevents bad or unverified code from moving forward. Second, the CI tool will notify the team automatically. Alerts are usually sent via email, Slack, or another tool, often tagging the developer who triggered the build. Third, the logs and reports will be reviewed. For example, developers might look at unit reports to find exactly what went wrong. Next, the developers debug the issue. They try to reproduce the failure locally or in a staging environment to identify the root cause. After that, the bug is fixed or the test logic is updated accordingly. And finally, the pipeline is re-triggered, either manually or automatically, to validate the fix. And that's how you troubleshoot a test stage failure in a CI/CD pipeline. It's all about catching problems early, fixing them fast, and keeping the pipeline clean. Thanks for watching DevOps by Bawasi. If you found this helpful, don't forget to like and subscribe for more DevOps and real-world how-to content. Until next time, keep learning, keep deploying.